Have you ever watched a game of billiards and wondered why does one ball stop the instant it hits another? Or maybe you have seen Newton's Cradle, where one ball swings, clicks, and another moves instantly, almost like magic. What's really happening here? The answer lies in collisions. In physics, collisions are not just simple bumps between objects. They reveal the hidden rules of motion, momentum, and energy. And when we understand these rules, everyday events suddenly make perfect sense. So, what exactly is a collision? A collision happens when two objects hit each other and they exchange energy and momentum. But depending on what happens to their energy after the collisions, we can classify them as elastic or inelastic. So, collisions can be of two types: elastic collisions and inelastic collisions. So, in today's lecture, we are going to discuss in details about the elastic collisions. So, what is elastic collision? Elastic collision is a type of collision in which both momentum and energy are conserved, which means that whatever momentum you have before collision, after the collision, the momentum must be the same. And whatever energy they possess before, the total energy before collision, that must be same after the collision. So now let's analyze the equations for momentum and energy for elastic collision. As we understand that in elastic collision, both momentum and energy is conserved. So we can consider this scenario. Before collision, we have two balls. One is moving toward right side with velocity v1 and another is moving toward left side with velocity v2. And after collision, the first ball is moving toward left side with velocity v1 and second ball is moving toward right side with velocity v2. So now the equation for conservation of momentum will be m1 v1, the momentum of first object, plus the momentum of second object and the momentum of first object after collision plus the momentum of second object after collision. So the momentum before the total momentum before collision must be same as the total momentum after collision. Similarly, we can also write for kinetic energy conservation the kinetic energy of the first ball plus the kinetic energy of the second ball before collision must be the same with the kinetic energy of the first ball after collision and the kinetic energy of the second ball after collision. We can also use these two relations, the one for the conservation of momentum and the conservation of energy in elastic collision. And by using this, we can drive a relationship that relates the velocities of the objects with each other. And that relationship is this: v1 plus v2 prime equals v2 plus v2 prime. So v1 is the velocity of the first object before collision and v1 prime is after collision. And similarly, for second object, v2 is the velocity before collision and v2 prime is after collision. So this relationship is very useful when we are solving the problems. We also asked that why a billiard ball stops when it hits another identical ball. And this is because the balls are identical, the mass is the same. So when this first ball hits the second one, it transfers all of its momentum to the second ball, and second ball continues with same momentum and energy. So this is due to elastic collision. So because masses are equal, collision is elastic, so it transfers momentum and energy to the second ball, and as a result the first ball comes to rest and the second ball moves away with the same velocity. Another question we ask about Newton's cradle, and as it clicks so perfectly with each swing, how this happened, and that is also because of elastic collision. In Newton cradles, with each swing, ball transfer its all momentum and energy to the next ball through elastic collisions, and this perfect transfer continues until the last ball receives the same momentum and swing out with nearly the same speed. Two objects of mass m1 equals 6 kg and m2 equals 2 kg approaches each other with speed v1 equals 2 meter per second and v2 equals 4 meter per second and undergo a head-on elastic collision. Find the velocities of the objects after the collisions. So now there are two objects and they are moving toward each other, and this side is taken to be positive, the left side is taken to be negative. So now let's see what is given. The mass of the first object, the mass of the second object 2 kg, the velocity of the first object is 2 meter per second, for the second object is 4 meter per second, and we need to find what is the velocity of first object after collision, and similarly what is the velocity of second object after collision. We can consider this one. Before collision both objects are moving toward each other, and after collision they are moving away from each other, and their velocities are different, and we represent the velocities of the object after collision with a prime. So now by conservation of momentum I can write m1 v1 plus m2 v2 equals momentum equals m1 v1 prime plus m2 v2 prime. So we need to put vector sign on them. By putting the values we will get this relation, and we can rearrange it and get this side will be 4 because 12 minus 8 is 4, and we have a minus sign because the second ball is moving toward negative side, and that's why we put negative sign here. And we don't know v1 prime plus we don't know v2 prime, so we have this relationship and there are two unknown quantities, so it is not possible to solve just with one equation. So we need another equation to find the one of the values. So for that we will use by equation of conservation of velocities, and v1 the velocity of the first object plus the velocity of first object but after collision equals v2 the velocity of second object plus the velocity of the second object after collision. So when we put this relation the values we will get another relation, and that in this relation also we don't know v2 prime and v1 prime. So we need to we also have two unknown, but if we combine these two equations, then we can get one of the value, and then in this way we can find. Now by multiplying the equation 2 with minus 2, we can get minus 2v2 prime plus 2v1 prime equals minus 12, and this is our equation 3. Now we can use equation 1 and 3 and add them, and I rewrite the equation 1, 6vi prime v1 prime plus 2v2 prime equals 4, and this is our equation 3, and by adding these two equations we can get this one. And here what happened is that these v2 prime and these minus v2 prime, they are same, hence they will cancel out, and these two terms will add up, and by adding these two you will get 8v1 prime equals minus 8. And if you rearrange this one, you will get the velocity of the first ball after collision equals minus 1 meter per second. Now if you place these values in equation 3 here, you can get this relation minus 2v2 prime plus 2 times minus 1 equals minus 12. And when you rearrange it, we can get v2 prime equals 5 meter per second. So this v1 is the velocity of the first ball in negative direction, 1 meter per second, and v2 is the velocity of the second ball in positive direction with velocity 5 meter per second. Okay, now students, this is your homework, page 169 and 170, 71, problems 28, 29, 32, 33, 40 and 42.